Well, hello, calculus students and seekers of truths. We continue our study of improper integrals, and now I'm going to work through this problem here, the integral from 1 to infinity of the function 1 over x. All right, so as before, we're going to deal with this infinity symbol by treating it as a limit. So let's see. This will be the limit as b, some variable or some constant in abstraction, approaches infinity between 1 and b of 1 over x dx. And the antiderivative of 1 over x is the natural log, and it's actually the natural log of the absolute value. But in this case, since we're dealing with only positive numbers, we can ignore the absolute value, and this is between 1 and b. And we're always taking the limit, in this case, as b approaches infinity. Okay, so we always bring the limit along with us when we're writing these expressions. So this is equal to the limit as b approaches infinity of the natural log of b minus the natural log of 1. Now, natural log of 1 is just 0, so we can ignore that. And if we were to put b, or put a very, very large number in here for the natural log, we would continue to get a very, very large number. So in the long run, this limit is going to approach infinity. Now, writing equals infinity is mathematically incorrect because infinity is not actually a number. You can't actually equal infinity. So we should write it in the correct terminology, and we should say that this integral is divergent. Now, to illustrate the point here of the trickiness of improper integrals, let me draw you the graph of 1 over x. It looks roughly like this. This is the graph of 1 over x. Now, there's another part down here too, but we're integrating here between 1 and infinity, so we don't really care about that other part. So now what we want to know is what's this area right here, right, from 1 to infinity. And if you compare these two graphs, the graph of e to the negative x and the graph of 1 over x, it's not intuitive, and it's not at all obvious why one of them should be finite and in fact have a value of something very simple, 1, and the other one would grow infinitely large forever. We will explore this idea a little bit later when we study infinite series, but for now, this is the approach, and the big picture here is, well, to use limits and to always be careful to work the problem out fully and avoid any sort of speculative assumptions. All right, so now you know how to take some basic integrals that are improper with the limits of integration being infinite. We will continue next in the next video with the second case, which is where there are vertical asymptotes in the graph. As always, keep working hard. Thank you for watching and have a wonderful day.